All right, this is problem number 7 in your 2.5 homework. So this is one where you're working backwards. You're given the zeros and you're trying to go back to come up with the polynomial. So we know that we're degree 3 and these are zeros, and then this is going to give us the leading coefficient. Okay, that's what we're going to use that for. Okay, this is not the leading coefficient, but it's going to determine, right, like it will lead to the leading coefficient. Okay, so the first thing we need to do is realize that if there's a degree 3, then there has to be 3 zeros, right, if we're including the complex numbers. Okay, so 4, 5i are zeros, but remember, if 5i is a 0, negative 5i is also a 0. So 4, 5i, and negative 5i are all zeros. Okay, so what we're going to do is we're going to say our function is going to look something like a, some number, times this x minus 4 times x minus 5i times x minus negative 5i. Alright, but I'm going to write that as, instead of minus negative, I'm going to write that as x plus 5i. Alright, minus a minus is a plus. Same for the complex numbers. Okay? Now, when you're doing these problems, always start with the complex numbers. And if there's another real, do the reals together and the complexes together. Okay, but pair the real zeros, factors, with the complex zero. The imaginary. Sorry, the reals with the reals, the imaginaries with the imaginaries. And then you'll see the imaginaries will cancel away. The i's will. So let's multiply this. We'll get a x times x is x squared. X times 5i is positive 5i. Negative 5i times x is 5ix. Negative 5ix. And then a negative times a negative is negative times a positive is a negative. 5 times 5 is 25. And then I times I is I squared. Okay, and then this a and the x minus 4 are still tagging along. Okay, but all of this is together. Okay, so these are going to cancel. They're the same, opposite signs. And then what you have to remember again is I squared equals negative 1. So I'm going to have a x minus 4 x squared minus 25, but we're multiplying 25 by I squared, which is negative 1. So what happens here is you end up with x minus 4 times x squared minus times a negative times a negative is a positive 25. Alright, and then finally multiply these together. So FOIL it again, x times x squared is x cubed. X times 25 is positive 25x. Negative 4 times x squared is negative 4x squared. Negative times a positive is a negative. 4 times 25 is 100. Alright, and then we're going to clean this up a bit, meaning write in descending order. So x cubed minus 4x squared plus 25x minus 100. Okay, so we've got the polynomials, like the ratio of the numbers to the coefficients of each term, but we don't know exactly what the leading coefficient is going to be. Okay, that's where this comes in. The f of 1 equals negative 234 is where this is going to come in. So f of x equals this. F of 1 then equals a times 1 cubed minus 4 times 1 squared plus 25 times 1 minus 100. So a times, this is 1 minus, because these are 1s, it's just going to be the coefficients. Alright, and when I combine all that together, I get a negative 78. Alright, so 1 minus 4 plus 25 minus 100. Well, what do I get when I plug 1 in? According to this problem, I get negative 234. So I should get negative 234. So that means if I divide, I'm going to come right here. If I divide both sides by negative 78, I get negative 234 over negative 78, right, which is 3. So that means my leading coefficient is 3, and so that means I get to go back to here, right, before I use the point to solve for A, the leading coefficient, and I multiply that 3 through. So 3 times x cubed is 3x cubed minus 12x squared. 3 times 25 is 75x minus 3 times 100 is 300. Alright, then I can plug that into my calculator. Go to the table, second graph of the table, and then look for those key points. So there's f of 1 is negative 234, like we're supposed to have. Okay, 4 is supposed to be a 0. Alright, 4 is a 0. I can see that down here. Okay, and then for the other one, for the complex or the imaginary zeros, you just have to plug in to your calculator this way. So write it out. Here where there's an x, replace x with 5i. Alright, remember I is second decimal point, and you get 0. Okay, and then if you go back and plug the negatives in front of the 5 i's everywhere, also get 0. Okay, so we have everything satisfied, meaning it's degree 3. Okay, 4 is 0, 5i, negative 5i are zeros, and then f of 1 equals negative 234. So this is the polynomial that does that.